These tiny worms appear to be doing something funny. Their movements, although random, are propelling them all in the same direction across a flat material. How does this worm conveyor work? And how might it help scientists build more efficient machines? The material responsible for this behavior is what's known as a non-reciprocal material. Normal or reciprocal materials respond to an external force in the same way, no matter what direction that force is applied. Non-reciprocal materials, on the other hand, are two-faced. They act one way under an applied force, but act the opposite way when the force changes direction. This turns out to be a useful feature if you want to channel a force in one way but not the other, the way a two-way mirror manipulates light, for example. While it's fairly easy to create one-way materials that direct forces like light and sound, it's proven much more difficult to make materials that guide mechanical motion. That's what makes the worm conveyor so special. The material that makes this motion possible is known as a hydrogel, a soft polymer-based material made mostly of water. A pure hydrogel, like the one shown here, is a reciprocal material. Under a shear force, the block deforms to the same extent, regardless of whether it's sheared left to right or right to left. But scientists discovered that if you fill the hydrogel with billions of nano-sized sheets of carbon, you get a non-reciprocal material. That's because of how each of these tiny sheets, made of a 2D material known as graphene oxide, responds under pressure. Pushing down on the sheets with enough force causes them to crumple or buckle, like a pillar carrying too much weight. By arranging these sheets in an angle inside the hydrogel, shearing along the buckling direction creates more deformation than shearing along the opposite direction. Now imagine what would happen if you placed an object, like a bead, on the surface of the gel. Quickly shearing the material to the left and then to the right would place the bead just to the left of where it started. Do this dozens of times per second, and you can do things like transport beads of liquid against the force of gravity or set a wheel in motion. This ability to turn random vibrations into useful work could make this non-reciprocal hydrogel a welcome add-on in devices prone to energy loss. Alternatively, those vibrations could come from the beating of tiny creatures, like our worms, providing an elegant method of choreographing their motion.